Hello everyone, welcome to my channel, and I think we have three circuits here. We have the first circuits here, LED, some transistor, also we have second circuits here, LED, transistor, resistors, and the third one we have LED, transistor, resistors. And it seems that the three circuits are identical, and we're using the yellow, golden LED. And it seems that the color is nice to the color is very nice. So let us check the circuit of this two. So this is our circuit. The first circuit is this, the second one, and the third one. So let us first see the circuit of this, and the circuit of this one is this transistor cyclic circuit, and this is our previous circuit. This is a cyclic configuration. The collector of the PNP is connected to the base of the NPN. That is cyclic or cyclic. And we made a lot of computation here and some given. The objective of the circuit is to use two transistors or the cyclic configuration, turning the LED on by conducting the transistor in saturation mode. Current flows here, also here, and also here. The transistor 1 and transistor 2 should be on to make this LED on, turn on, and we have that kind of circuit. This is cyclic circuit, and the circuit of this one is this transistor cyclic PNP side. That is the circuit name, and this is the circuit. The difference with this, with the previous one, is the LED is in the collector side of the NPN as a load. Here the LED is in the PNP side, emitter side of the PNP. And the objective of this circuit is to conduct the transistor in saturation mode. And we successfully conducting the transistor in saturation mode, and it is working. The two are working. Current flows here when you close the switch, also here. And since this is our previous circuit, we calculated a lot of values here of all the resistors and also the given data of the data sheet in the transistor and LED. And we have here a new circuit. This circuit is this transistor PNP-NPN complementary, and it has a different design or circuit diagram here. The PNP base is connected to the collector, unlike the cyclic or cyclic. PNP collector is connected to the base of the NPN. Collector of the PNP is connected to the NPN, the base. But here, the base of the PNP is connected to the collector. That is our new circuit. Just like here. So this base is connected to the collector of the NPN. We connect this instead of connecting it to the ground. And the objective of this design is to conduct the two transistors in saturation mode to pass this LED to the ground, turning the LED on. And we have the given here, given data of LED in the transistor, and that's our circuit, and it's working. So let us see the circuit of this new transistor. Let us use the Kirchhoff's voltage law to find the voltage drop at the RD and RE. Voltage supply, the voltage drop resistor, LED transistor, and to the RE1. We got here Kirchhoff's voltage law. Sum of all voltages in the loop is equal to 0. Substitution here given. And you see this voltage at the collector emitter, saturation of Q1, negative 0.25, because this is PNP. That is given the data sheet of the transistor PNP. Collector 2, emitter. This is the KBL here. So we get now this 3.25 volts. The sum of the voltage drop across the resistor and the RE1. I'm using RE1 as a resistor here, not RC1, RE1. It's still okay. Just for calculation. So we know the voltage drop of the two resistors, just divided by 2, we got 1.625 RE, and the voltage drop here 1.625. 1.625. Using Ohm's law, we got now this voltage drop at RD and the current of the resistor is equal to the LED current because they are in series. So we got 100 ohms available resistor, but this is the actual computation, 81.25 ohms. Let us now find the current gain at the resistor 1. Using current gain formula, HF is equal to IC1 over IB1. Since we know the collector current is the current of the LED, HFP of the first transistor is 300 given data sheet. I use the same formula as the NPN here, since this is PNP, because PNP is almost the same as NPN. The difference is NPN is pulling the current, PNP is pushing the current. So still I'm using the same formula for HFP, current gain. So we got now base current up, and we have the transistor formula for that. IE is equal to IC over IB. We know the IC1 and IB1. We got IE1, IC1 plus IB1. Using Ohm's law, since we know the voltage drop at RE, and the current, this one, we get the value of 80.98, but I use 100 ohms. So let us now transistor on, turn on. Just using the formula voltage supply to conduct this transistor to turn on. We need voltage supply here to know the voltage drop here. Voltage supply minus voltage drop here minus BE on transistor. We need to know the voltage drop here to conduct this transistor, to switch this transistor on using that KBL or Ohm's law. Low current, voltage supply here, voltage drop here minus voltage drop VBE. Substitution, we got 4.1 voltage drop by using that formula, just to conduct this transistor, to know to turn on this transistor, in short. Let us find the current gain here, transistor 2. using the same formula, HAP, IC over IB. IC2 is equal to the base current 1. IC2 here, current collector, is equal to the base current of the first transistor. IB is equal to IC, since they are in series. Substitution, we get the data, HAP Q2, 400 in data sheet, transistor, using Ohm's law. RB2 now is 6 million ohms, almost. And I'm using 6.22 mega ohms. It seems there's a very big resistance value here. But the circuit is working. That is our circuit. And using KBL again in this green line to find the voltage drop at the RE2. Voltage supply passing to the resistor, LED, first transistor, second transistor, into the resistor. So we get out this one. Very long equation. It's very long. By substitution, given the data sheet of each, we get 2.575. And since we know the voltage drop here, we're now using the transistor formula. IC2 plus IB2 is equal to IE2. Since IB1 is equal to IC2, IC2 is equal to IB1. We got now IE2, very small current. Using Ohm's law, since we know all the values, the substitution, we get 40 kilo ohms, may available resistor. Actual value is 38336.70, but I use 40 kilo ohms. So we know all the values of the resistor here, all the values, and the circuit is working, and it is not burning. It means we successfully conducting the two transistors in saturation mode, just like this one and this one. And it means our formula is working. I can say that our formula is correct or wrong, but at least our formula is working. Just looking at this circuit, we have here now the actual values of each component. 100, 40 kilo ohms, 6.22 mega ohms. Very big, almost what a very big resistance value. And this is our layout. We have 6 resistors, transistor, transistor here. We have a resistor and LED. We have here our resistors and LED, and that is the layout. And we have the parts here. That is the circuit diagram, and that is the layout. So thank you for watching my video, and bye bye.